The silver thread sequestered within the glass capillary of a traditional medical thermometer represents a profound defiance of the fundamental laws of chemical behavior as understood by the classical world. For centuries, the observation of this substance has fascinated scientists and laypeople alike, primarily due to its status as the only metallic element that remains in a liquid state at standard temperature and pressure. To the human eye, it appears as a shimmering, hyper-reflective fluid, a living silver that rolls across surfaces with a distinct lack of friction and a surface tension so high that it refuses to wet the materials it touches. While common intuition suggests that metals are synonymous with structural rigidity and crystalline solidity, element 80 exists in a permanent state of molten flux.
This anomaly is not merely a quirk of the periodic table. It is a macroscopic manifestation of the most advanced principles of modern physics, specifically Albert Einstein's special theory of relativity. The liquid state of Mercury at room temperature serves as a physical glitch in the classical narrative of matter, revealing that at the atomic level, the fabric of space and time is inextricably linked to the chemical properties of the elements found in a common household drawer. The explanation for this liquid existence lies in the extraordinary velocity of the electrons orbiting the Mercury nucleus. With 80 protons exerting a colossal positive charge, the innermost electrons of a Mercury atom are subjected to an immense electrostatic pull. To avoid spiraling into the nucleus, these electrons must travel at relativistic speeds, reaching approximately 60% of the speed of light. At these velocities, the effects predicted by Einstein become significant. The mass of the moving electrons increases by nearly 20%. This increase in mass causes the electrons to gravitate closer to the nucleus, effectively shrinking the radius of the 6s atomic orbital. This relativistic contraction is so pronounced in Mercury that the outer electrons are pulled inward with such force that they become unavailable for the chemical bonding that typically holds metal atoms together in a solid lattice. While other metals, such as silver or copper, form strong metallic bonds by sharing their valence electrons in a sea of communal charge, the atoms of Mercury remain chemically isolated, held together only by weak van der Waals forces. Consequently, Mercury behaves more like a noble gas than a traditional metal, lacking the structural coherence to solidify until the temperature drops to -38 degrees Celsius. This is the reality of the element, a heavy metal that remains fluid simply because its subatomic particles are moving too fast for the laws of traditional chemistry to capture them. This relativistic phenomenon is not unique to Mercury's physical state, but also explains the distinct aesthetic properties of other heavy elements, most notably gold. Element 79, situated directly adjacent to Mercury on the periodic table, possesses a characteristic yellow luster due to the same relativistic contraction of its 6s orbitals, which shifts the absorption of light toward the blue end of the spectrum, leaving only the warm, golden hues to be reflected. In Mercury, the effect is even more extreme, leading to a complete lack of visible light absorption across the spectrum, resulting in its perfect, mirror-like reflectivity. When a thermometer breaks and releases its contents, the resulting silver globules are not merely an environmental hazard. They are individual droplets of a material that is literally too heavy for its own atomic structure to support in a solid form. The fascination with these magic beads has historically led to dangerous levels of exposure, as children and adults alike have attempted to manipulate the spheres, unaware that the high vapor pressure of the element allows it to transition into an invisible, odorless, and highly neurotoxic gas, even at room temperature. The presence of mercury in the domestic environment, though now largely phased out in favor of digital alternatives, represents a historical reliance on the element's unique conductive and thermal properties. Beyond the thermometer, mercury served as the silent engine of early automation, acting as the primary component in tilt switches and thermostats. Its high electrical conductivity, combined with its fluid nature, made it the perfect material for creating a reliable electrical contact that could be opened or closed by the simple movement of a physical device.
For decades, the temperature of homes and the functionality of industrial machinery were regulated by the motion of a small silver bead, rolling back and forth to complete a circuit. In the realm of dentistry, the element's ability to dissolve other metals, a process known as amalgamation, allowed for the creation of durable tooth fillings. By mixing liquid mercury with a powdered alloy of silver and tin, dentists could create a pliable paste that could be packed into a cavity and would subsequently harden into a solid metallic restoration. This application highlights the profound irony of element 80. It is a material that humans have literally placed inside their own bodies to maintain health, while simultaneously being one of the most potent environmental poisons in existence. The transition from viewing mercury as a technological marvel to a biological threat has been one of the most significant shifts in the history of public health.
The very properties that make it useful, its fluidity, its density, and its ability to amalgamate, are the same characteristics that allow it to infiltrate biological systems with ease. It is a substance that defies containment. It can evaporate through the air, dissolve into water, and accumulate in the tissues of living organisms. Because it is an element, it cannot be broken down or destroyed. It can only be moved from one chemical state to another. This permanence makes the management of mercury a global priority, as the pollution generated by industrial processes or the artisanal mining of gold can travel thousands of miles through atmospheric currents before settling into the food chain. The history of the element is a cautionary tale of human curiosity and industrial progress, where the pursuit of a living silver has left a legacy of environmental contamination that will persist for centuries.
The scientific and industrial narrative of mercury is so dense with complexity and contradiction that it requires a comprehensive exploration to fully grasp its impact on human civilization. To ensure that these intricate connections between fundamental physics and daily life are explored with the depth they deserve, the support of the audience is essential. Engaging with the content by subscribing to the channel and providing a comment with the phrase "liquid metal" directly assists in maintaining the reach of this educational exploration, ensuring that the critical history of the elements remains accessible in an increasingly crowded digital landscape. The support of the viewer is the primary mechanism that allows for the continued production of high-quality, research-driven content that challenges common perceptions of the material world. The journey into the heart of element 80 reveals a reality where the most beautiful substances are often the most dangerous, and where the laws of the universe are written in the behavior of a single, shimmering drop of liquid. The etymology of the element further reflects its dual nature. Historically known as hydrargyrum, from the Greek words for water and silver, the symbol Hg remains a tribute to its liquid metallic state. In ancient alchemy, mercury was considered one of the three fundamental substances of the universe, alongside salt and sulfur, representing the volatile and transformative principle of matter. It was the Hermes of the elements, a messenger between the solid and the fluid, the terrestrial and the divine. This symbolic importance translated into a wide array of medicinal uses throughout the Middle Ages and the Renaissance, where mercury was prescribed for everything from skin conditions to syphilis. The mercurial treatments of the past were often as lethal as the diseases they sought to cure, as patients slowly succumbed to the tremors, hallucinations, and organ failure associated with chronic poisoning. The medical history of mercury is a testament to the fact that for much of human history, the aesthetic allure of a substance was often mistaken for its therapeutic potential. In terms of physical density, mercury occupies a tier of its own among common fluids. With a density of 13.6 grams per cubic centimeter, it is over 13 times heavier than water. This extreme mass allows for the creation of barometers and manometers of manageable size,
A column of mercury only 76 centimeters high is sufficient to balance the entire weight of the Earth's atmosphere. If one were to use water for the same purpose, the barometer would need to be over 10 meters tall. This density also creates a surreal physical experience. An iron cannonball or a lead weight will float on the surface of a pool of mercury, as if it were a piece of cork on a pond. The buoyancy of such heavy materials in the liquid metal is a striking visual reminder of the element's atomic weight and the compact packing of its liquid atoms. This property was utilized in early lighthouse designs, where the massive Fresnel lenses, weighing several tons, were floated in a circular trough of mercury to allow them to rotate with minimal friction, projecting a beam of light across the ocean with the push of a single finger. The environmental persistence of mercury is exacerbated by its cycle between the atmosphere, the land, and the sea. When elemental mercury is released into the air, primarily through the combustion of coal or the processing of ores, it can remain in the gaseous phase for up to a year, traveling across continents before it is oxidized and washed out of the sky by rain. Once it enters the aquatic environment, it undergoes a metabolic transformation by anaerobic bacteria, which convert the inorganic metal into methyl mercury, a highly potent organic toxin. This is the form that enters the food chain, accumulating in the tissues of predatory fish like tuna and swordfish. Unlike the elemental mercury in a thermometer, methyl mercury is easily absorbed by the human gastrointestinal tract and can cross the blood-brain barrier with terrifying efficiency. This bioaccumulation represents the ultimate hidden mechanism of the element, where the industrial emissions of the past return to the dinner tables of the present, demonstrating that there is no away when it comes to the disposal of element 80. The technological legacy of mercury is also found in the history of mirrors. Before the development of the silvering process using silver nitrate, high-quality mirrors were produced using a tin mercury amalgam. A thin sheet of tin foil was spread over a flat glass pane, and liquid mercury was poured over it, forming a reflective coating that provided the elite of the 17th and 18th centuries with their first clear glimpses of their own reflections. The Hall of Mirrors at the Palace of Versailles was originally lined with these mercurial surfaces, creating an environment of unprecedented opulence. However, the production of these mirrors was a death sentence for the craftsmen involved, as the constant exposure to mercury fumes led to the systemic degradation of their health. The vanity of the aristocracy was quite literally reflected through the suffering of laborers who inhaled the liquid silver as they worked. This historical context adds a layer of moral complexity to our appreciation of antique craftsmanship, revealing the hidden human cost of the materials that shaped the aesthetic of the modern world. As we move forward in our analysis, it is clear that mercury is not just a metal. It is a physical intersection of relativistic physics, ancient alchemy, industrial utility, and biological tragedy. It is an element that demands a sophisticated understanding of the world, as its presence is often most dangerous when it is least visible. From the rivers of immortality in ancient tombs to the microscopic sensors in modern electronics, mercury has played a role in the human story that is as fluid and unpredictable as the metal itself. We have transitioned from a species that worship the element as a divine elixir to one that views it as a critical environmental challenge. Yet, we remain captivated by its impossible silver glow. The following blocks will delve into the cosmic origins of this heavy metal and the historical madness it has induced in those who sought to master it, revealing that the story of element 80 is, in many ways, the story of humanity's struggle to survive its own curiosity. Mercury remains a mirror, reflecting not only our faces, but also our capacity for both brilliant innovation and profound destruction. The presence of Mercury on the periodic table as element 80 signifies its membership in an elite group of heavy elements whose existence cannot be explained by the standard life cycle of a star. While the majority of the chemical elements that constitute the Earth and the human body are forged through the steady process of nuclear fusion within the cores of suns or during the explosive death of a massive star in a Type II supernova, the synthesis of mercury requires an environment of even more extreme physical parameters.
To create an atom with 80 protons and a large complement of neutrons, the universe must engage in a process known as the R process, or rapid neutron capture. This occurs in the most violent and energetic events known to modern astrophysics, most notably the collision of two neutron stars, a phenomenon referred to as a kilonova. Neutron stars are the collapsed remnants of giant suns, consisting of matter so dense that the laws of conventional physics begin to break down. A single cubic centimeter of this material possesses a mass of approximately 100 million tons. When two such objects are drawn together by the curvature of spacetime, their eventual merger releases a gravitational pulse that vibrates across the entire galaxy, accompanied by a flux of neutrons so intense that it momentarily overcomes the repulsive forces of the atomic nucleus.
During the final milliseconds of a kilonova, the surrounding space is flooded with free neutrons at densities exceeding 10 to the 22nd power, 10 to the 22nd power grams per cubic centimeter. In this high-energy environment, seed nuclei are bombarded by neutrons at a rate faster than they can undergo radioactive beta decay. This allows for the assembly of extremely heavy, neutron-rich isotopes that eventually stabilize into elements like gold, platinum, and mercury. Every milligram of mercury that has ever been extracted from the Earth's crust is essentially a collection of __15__ from these catastrophic stellar mergers. The thermal and gravitational energy required to forge the 81 stable and unstable isotopes of the Mercury series is billions of times greater than the total energy output of the Sun over its entire multi-billion-year lifespan. Consequently, the rarity of Mercury is a direct reflection of the rarity of kilonovae in the history of the Milky Way. The material found in a modern industrial setting is a physical record of the most intense pressures and temperatures the universe can manifest, preserved through eons of cosmic expansion and planetary accretion.
Following its synthesis in a distant kilonova, the mercury produced was ejected into the interstellar medium, becoming part of the vast molecular clouds of gas and dust that eventually formed our solar system. Approximately 4.5 billion years ago, as the protoplanetary disk began to coalesce under the influence of gravity, Mercury was incorporated into the cooling mass of the Earth. However, its distribution within the planet was governed by its specific chemical affinities. In the early molten Earth, a process known as planetary differentiation occurred, where the heaviest elements sank toward the center. While iron and nickel formed the core, other elements were sorted according to their preference for bonding with either silicates or metals. Mercury is classified as a chalcophile element, meaning it possesses a high affinity for sulfur. Instead of sinking entirely into the iron core, a significant portion of the Earth's mercury remained trapped in the mantle and crust, primarily in the form of mercury 2 sulfide, or cinnabar. This bright red mineral represents the __16__ of element 80, a stable crystalline structure that prevents the toxic metal from interacting with the biosphere. The geological history of Mercury is inextricably linked to volcanic activity and the movement of the Earth's tectonic plates. Most concentrated deposits of cinnabar are located in regions of past or present hydrothermal activity, where superheated fluids traveling through the crust have dissolved mercury from the surrounding rocks and redeposited it in concentrated veins. The largest such deposit in the world, the Almaden mine in Spain, has been exploited for over 2,000 years and was formed through volcanic processes during the mercury-rich Paleozoic and Mesozoic eras. Because mercury is highly volatile, possessing a boiling point of only 356 degrees Celsius, it can be easily liberated from its mineral form by heat. In the natural world,
Volcanic eruptions are the primary source of mercury emissions into the atmosphere, releasing thousands of tons of gaseous mercury annually. This natural cycle has existed for billions of years, but the baseline levels of atmospheric mercury were historically very low until the advent of the Industrial Age. The persistence of mercury in the Earth's environment is a consequence of its atomic stability. Unlike heavy elements such as uranium or thorium, the primary isotopes of mercury are stable and do not undergo radioactive decay over geological timescales. This means that the total amount of mercury on Earth has remained constant since the planet's formation. It is merely redistributed through the various reservoirs of the atmosphere, oceans, and crust. From a deep time perspective, Mercury is an immortal witness to the Earth's evolution. It has been cycled through the mantle, erupted from volcanoes, absorbed by the oceans, and sequestered back into sedimentary rocks over millions of years. Its presence in the deep oceans today is a mixture of primordial mercury from the Earth's interior and modern mercury released by human activity. The element acts as a chemical tracer of the planet's internal dynamics, its movement dictated by the laws of thermodynamics and the shifting temperatures of the crust. The peculiar relationship between mercury and the biology of the Earth is characterized by a complete lack of functional utility. While elements like iron, zinc, and even trace amounts of selenium are essential for the operation of biological enzymes and the maintenance of life, mercury is entirely exogenous to the evolutionary process. There is no known organism that utilizes mercury as a necessary component of its metabolism. On the contrary, life has spent billions of years evolving mechanisms to exclude or detoxify heavy metals that disrupt cellular function. The natural sequestration of mercury within cinnabar meant that early life forms were rarely exposed to high concentrations of the metal. It is only when geological or technological processes break this cinnabar seal that mercury enters the biosphere, where its ability to mimic other essential minerals allows it to infiltrate and dismantle the biochemical machinery of living cells. The deep time perspective reveals mercury as an elemental outsider, a cosmic byproduct that belongs to the world of high-energy physics rather than the world of organic chemistry. The volatility of mercury also plays a critical role in its cosmic and terrestrial narrative. Because mercury can exist as a gas at temperatures common in the Earth's atmosphere, it is the only metal that participates in a global atmospheric cycle similar to that of water or carbon. A mercury atom released from a volcanic vent in the Andes can remain in the atmosphere for up to a year, circulating the globe multiple times before it is oxidized and washed into the Pacific Ocean by rainfall. This global mobility is a unique feature of element 80, allowing a localized event, whether a natural eruption or an industrial emission, to have planetary consequences. The story of Mercury is therefore one of inescapable interconnectedness. The fundamental physics of the mercury atom, established in the fire of a kilonova, dictate its behavior in the modern environment, ensuring that the element remains a constant, moving presence in the air we breathe and the water that sustains the global ecosystem. Furthermore, the study of mercury isotopes provides scientists with a powerful tool for reconstructing the history of the Earth's atmosphere and oceans. By analyzing the infinitesimal variations in the mass of mercury atoms found in ancient sediments and ice cores, researchers can determine the historical rates of volcanic activity and even track the impact of massive asteroid collisions. The isotopic signature of Mercury acts as a high-resolution geological clock, recording the fluctuations of the planet's chemical state over hundreds of millions of years. This science of isotope geochemistry relies on the fact that different physical and chemical processes, such as evaporation, condensation, and microbial transformation, preferentially move different isotopes of mercury. These subtle shifts, though invisible to the naked eye, are permanent records of the Earth's environmental past, allowing us to see how the planet managed its __quote _21 __ burden long before the emergence of the human species. The transition from a planet where Mercury was safely locked away in deep geological strata to one where it is a pervasive environmental contaminant is a relatively recent event in the context of deep time. For the vast majority of the Earth's history, the concentration of reactive mercury in the surface environment was negligible. The human discovery of cinnabar and the subsequent development of metallurgy represents a sudden and violent acceleration of the natural mercury cycle. We have taken a material that was concentrated by the tectonic forces of the Earth over millions of years and released it into the atmosphere and oceans in a matter of centuries.
This shift is not merely a change in geography, it is a fundamental alteration of the Earth's chemical landscape. The mercury that is currently accumulating in the Arctic ice or the deep sea trenches is the same mercury that was forged in the collision of neutron stars, now liberated from its crystalline prison to circulate through the modern world. As we contemplate the cosmic scale of Mercury's history, it becomes clear that we are dealing with a substance that is fundamentally alien to the delicate balance of biological life. Its origins in the most violent events in the universe and its unique relativistic properties make it a material of extreme density and volatility. Nature's solution to the problem of mercury was to hide it deep within the Earth, bound to sulfur in a stable, immobile form. The human decision to extract and utilize this liquid silver has brought us into direct contact with a cosmic force that our biology was never designed to handle. The deep time of mercury reminds us that we are participating in a cycle that spans billions of years and millions of kilometers. We are not just using a metal, we are interacting with the debris of dead stars, a substance that has survived the formation of the solar system and the cooling of the Earth to become one of the most significant challenges of our technological age. The following blocks will explore how this cosmic outsider became a central figure in the madness of human history, as empires and individuals alike fell under the spell of its impossible, shimmering glow. The intersection of human ambition and the toxic reality of Mercury is most vividly illustrated through the historical obsession with immortality and the industrial pursuit of fashion, both of which resulted in profound neurological catastrophes. For millennia, the unique physical properties of element 80, its fluidity, its reflective brilliance, and its ability to dissolve other metals, led ancient civilizations to categorize it not as a mere mineral, but as a substance of spiritual and biological significance. In the context of ancient Chinese alchemy, mercury was perceived as the liquid soul of the earth, a material that possessed the power to transcend the decay of the organic world. This belief found its most extreme expression in the life and death of Qin Shi Huang, the first emperor of a unified China. His pursuit of eternal life was centered on the consumption of alchemical elixirs, many of which were composed of cinnabar and liquid mercury. The irony of this pursuit is a matter of documented biological record. The very substance the emperor believed would grant him divinity was the precise agent of his mental and physical dissolution. The toxicology of mercury ingestion is a progressive and devastating process that centers on the element's ability to bypass the body's natural defenses. When Qin Shi Huang consumed mercury-laden pills, the element entered his bloodstream and, due to its lipid solubility, easily crossed the blood-brain barrier, a specialized interface intended to protect the central nervous system from circulating toxins. Once inside the brain, mercury atoms exhibit a high affinity for the sulfhydryl groups found in essential proteins and enzymes. This molecular binding disrupts the cellular scaffolding and inhibits the function of neurons, leading to the systematic degradation of the prefrontal cortex and the limbic system. Historical accounts of the emperor's final years describe a man descending into profound paranoia, isolation, and erratic aggression, symptoms that modern neurology recognizes as the hallmark of chronic mercury poisoning. The ruler who unified a warring continent ended his life as a prisoner of his own neurochemistry, driven to madness by the immortality he sought to drink. The legacy of this obsession is physically preserved in the emperor's massive, unexcavated mausoleum at Mount Li.
According to the records of the historian Sima Qian, the central burial chamber contains a miniature representation of the Chinese Empire, complete with 100 rivers and seas, crafted from flowing mercury, kept in motion by mechanical systems. For centuries, these accounts were dismissed as mythological exaggeration, yet modern geological surveys conducted in the 1980s and 2000s have provided empirical evidence to support the legend. Using soil analysis and vapor sensing technology, researchers identified a massive __27__ directly above the burial mound. The concentrations of mercury in the soil are up to 100 times higher than the surrounding regional background levels, suggesting that hundreds of tons of the liquid metal remain sequestered within the subterranean structure.
The emperor does not merely rest in a tomb. He is encased in a permanent, high-concentration vapor of element 80, a toxic monument to the belief that a liquid metal could serve as a bridge to eternity. As the centuries progressed, the quote, 28 of Mercury shifted from the palaces of emperors to the workshops of the Industrial Revolution, where the element became a silent architect of professional disease. During the 18th and 19th centuries, the production of felt hats, the standard attire for the European and American middle class, relied on a process known as, quote, _29_. To make the coarse fur of rabbits or beavers pliable enough to be felted, craftsmen treated the pelts with a solution of mercury nitrate. As the fur was dried and processed in poorly ventilated rooms, the mercury nitrate would decompose, releasing a steady stream of elemental mercury vapor into the workspace. The laborers, often working long hours in confined spaces, inhaled these vapors daily,
allowing the mercury to accumulate in their nervous systems over years of employment. The resulting clinical condition, known as erethism mercurialis, or __30__, remains one of the most poignant examples of industrial poisoning in history. The symptoms were not merely physical, such as the __31__, a severe intention tremor that made it impossible for workers to perform fine motor tasks, but also profoundly psychological. Chronic exposure to mercury vapor results in a total erosion of the victim's personality. Affected individuals suffered from extreme social anxiety, pathological shyness, irritability, and sudden outbursts of irrational fear or rage. The expression "mad as a hatter" was not a literary invention of Lewis Carroll, but a common diagnostic observation of a class of workers whose very identities were being chemically erased by their profession.
The mercury did not just damage their bodies, it hollowed out their cognitive existence, leaving a trembling shell of a human being whose neurological signaling had been permanently short-circuited by the heavy metal atoms occupying their synaptic gaps. The molecular mechanism behind this madness is found in mercury's interference with tubulin, a protein essential for the structural integrity of the cytoskeleton within neurons. In a healthy brain, tubulin polymers form microtubules that act as the transportation system for nutrients and neurotransmitters throughout the long axons of nerve cells. When mercury ions enter the neuron, they bind to the tubulin molecules, causing the microtubules to collapse and disintegrate. This results in the __35__ of the nerve fibers, effectively stripping the brain of its internal infrastructure. Without these pathways, the brain cannot maintain its connections, leading to the rapid death of brain cells and the atrophy of the cerebral cortex. This process is objective, mathematical, and irreversible. Whether it was an emperor in 210 BC or a hat maker in 1850 AD, the chemical interaction between mercury and human biology remained the same. The element dismantled the physical basis of the mind. The drama of mercury also extended into the world of early modern medicine, where it was utilized as the primary treatment for syphilis for nearly 400 years. Known as
__36__, syphilis was a devastating pandemic that required aggressive intervention, and mercury was the only substance that appeared to have any effect on the visible symptoms of the disease. Patients were subjected to __37__, where high concentration ointments were massaged into the skin, or placed in __38__, where they inhaled mercury vapors. This led to the famous medical adage, __39__. While the treatment often suppressed the external lesions of the disease, the side effects were often more lethal than the infection itself. Chronic mercurialism led to the loss of teeth, the ulceration of the gums, and the failure of the kidneys and liver. The medical establishment of the time viewed these toxic reactions as a sign that the treatment was working, unaware that they were witnessing the systemic poisoning of their patients. In the mid-20th century, the drama of mercury reached a terrifying climax in the coastal town of Minamata, Japan. This event serves as the definitive turning point in the global understanding of organic mercury and bioaccumulation. A local chemical factory had been discharging inorganic mercury waste into Minamata Bay for decades. However, the true danger emerged when anaerobic bacteria in the seabed transformed this inorganic metal into methyl mercury, the most potent neurotoxic form of the element. This organic mercury was absorbed by the local fish and shellfish, which were the primary food source for the local population. The residents began to exhibit a mysterious set of symptoms: loss of motor control, narrowing of the visual field, and severe cognitive impairment. This became known as Minamata disease. Unlike the tremors of the Hatters, Minamata disease often resulted in permanent, debilitating physical deformities and neurological devastation in children born to mothers who had consumed the contaminated fish, as methyl mercury easily crosses the placental barrier. The Minamata tragedy revealed that mercury is not just a localized poison, but a substance capable of its lethality as it moves through the environment. It demonstrated that human industrial activity could trigger a biological feedback loop, where the element returns to the human body in a far more dangerous form than it was released. This realization ended the era of viewing mercury as a manageable industrial tool and placed it firmly in the category of a global existential threat. The international response culminated in the Minamata Convention on Mercury, a global treaty designed to phase out the use of the element in industrial processes and products. This shift represents a fundamental change in the human story. We have moved from worshipping the __41__ to systematically attempting to erase its presence from our technological and domestic lives. Despite these efforts, the __42__ of mercury persists in the modern world through the unregulated artisanal gold mining industries of the global south. In regions such as the Amazon basin and sub-Saharan Africa, millions of informal miners use mercury to extract gold from crushed ore. The mercury is mixed with the sediment to form a gold-mercury amalgam, which is then heated over an open flame to vaporize the mercury and leave the pure gold behind. This process releases approximately 1,000 tons of mercury vapor into the atmosphere every year, accounting for nearly 40% of all global anthropogenic mercury emissions. The miners and their families inhale the concentrated vapors, repeating the tragedy of the Victorian hatmakers on a massive global scale. The gold that enters the global market is often, '43 by this mercurial legacy, a reminder that our modern wealth is still frequently built upon the biological sacrifice of those who handle the __44__. Reflecting on these historical and contemporary tragedies, it becomes clear that mercury is an element that demands a profound respect for the boundaries of biological life. It is a material that exists on a scale of physics and chemistry that is fundamentally incompatible with the delicate requirements of a functioning nervous system. The drama of Qin Shi Huang, the madness of the Hatters, and the suffering of the people of Minamata are all parts of a single narrative. The human attempt to integrate a cosmic outsider into the intimate systems of our society. Mercury does not have a, quote, 45 to cause madness. It simply possesses a specific atomic structure that makes it an inevitable disruptor of the protein bonds that allow us to think, move, and feel. We are the ones who have consistently broken the, quote, 46, and we are the ones who must live with the consequences of inviting the, quote, 47 into our world. The following block will explore the hidden mechanisms of mercury in our current environment, from the seafood on our plates to the complex sensors in our electronics, revealing that the atomic age of mercury is far from over. The contemporary presence of mercury in the global environment and industrial infrastructure is characterized by a state of quote, 48 where the element functions as a hidden variable in both the biological food chain and the mechanical systems that define modern life. While the most visible domestic applications of mercury, such as thermometers and barometers, have been systematically replaced by solid-state electronics, the element remains an unavoidable component of global industrial output and environmental chemistry. The most significant quote 49 through which mercury interacts with human biology today is the process of biomagnification, a phenomenon that transforms trace environmental pollutants into concentrated neurotoxic doses. This process begins in the anaerobic sediments of the world's oceans and wetlands, where specific lineages of sulfate-reducing and iron-reducing bacteria perform a metabolic transformation of inorganic mercury. These microorganisms possess a specialized gene cluster known as HGCAB. HGCAB, which encodes the proteins required to attach a methyl group to the mercury atom, creating methylmercury, CH3Hg plus CH3Hg+. This organic form of mercury is fundamentally different from its metallic counterpart. It is highly mobile, chemically stable, and possesses a profound affinity for biological tissues. The trajectory of methylmercury through the marine ecosystem is a study in exponential concentration. Because methylmercury is not easily excreted by living organisms, it accumulates within the proteins of the body, a process known as bioaccumulation. As energy moves up the trophic levels of the food chain, from microscopic phytoplankton to small crustaceans and eventually to predatory fish, the concentration of mercury increases by approximately 1 order of magnitude at each step. By the time the element reaches apex predators such as Atlantic bluefin tuna, swordfish, or certain species of shark, the concentration of mercury can be several million times higher than the levels found in the surrounding seawater. For the human consumer, this means that the ingestion of a single tuna steak represents the biological distillation of mercury from thousands of gallons of ocean water and millions of smaller organisms. The biochemical danger of methylmercury lies in its ability to mimic essential nutrients. Due to its chemical structure, methylmercury combined with the amino acid cysteine to form a complex that the human body mistakes for methionine, an essential building block of proteins. This molecular mimicry allows the mercury to hijack the LAT1 neutral amino acid transporter, which serves as the primary gateway across the blood-brain barrier. Consequently, the brain's natural defense system, designed to exclude toxins, actively facilitates the entry of methylmercury, allowing it to begin the systematic destruction of neurons described in previous scientific observations. Simultaneously, The global supply of gold remains inextricably linked to the ongoing use of mercury in artisanal and small-scale gold mining, ASGM. This sector, which accounts for approximately 20% of the world's gold production, relies on the centuries-old technique of mercury amalgamation. In the remote regions of the Amazon basin, Southeast Asia, and Sub-Saharan Africa, miners mix liquid mercury with crushed ore to create a silver-colored amalgam. The mercury acts as a chemical magnet, pulling the microscopic grains of gold out of the surrounding silt and rock. To recover the gold, the miners must then heat the amalgam over an open flame, often using a simple blowtorch or a handheld furnace. This process causes the mercury to vaporize instantly, leaving behind the pure gold, but releasing massive quantities of elemental mercury gas directly into the local environment and the lungs of the workers. This is not a localized problem. The vaporized mercury enters the global atmospheric cycle, where it can remain suspended for up to a year, traveling across oceans and continents before being deposited in distant ecosystems through rainfall. The gold ring on a consumer's finger in a modern metropolis may be the end product of a process that has permanently contaminated a river system thousands of miles away, demonstrating the inescapable global footprint of element 80. The industrial utility of mercury is also found in the high-efficiency lighting systems that illuminate large-scale infrastructure, such as warehouses, streetlights, and sports stadiums. High-intensity discharge, HID lamps, and fluorescent tubes utilize a small amount of mercury vapor to produce light. When an electrical current passes through the mercury-laden gas, it excites the mercury atoms, causing them to emit ultraviolet UV radiation. In a fluorescent lamp, this UV light strikes a phosphor coating on the inside of the glass tube, which then glows with visible light. Despite the rise of light-emitting diode (LED) technology, mercury-based lighting remains a significant component of the global electrical grid due to its historical cost-effectiveness and high luminosity. The management of these lamps at the end of their life cycle represents a major logistical challenge in waste management, as a single broken bulb can release enough mercury vapor to contaminate a small room beyond safe occupancy limits. This necessitates specialized recycling programs designed to capture the mercury and prevent its entry into the municipal waste stream, highlighting the continuous technological effort required to isolate the liquid silver from the biosphere. In the history of automation and electrical engineering, mercury served as the primary medium for high-precision switching and sensing. The mercury switch is a masterpiece of simple physics, consisting of a glass bulb containing two electrical contacts and a single drop of liquid mercury. When the bulb is tilted, the mercury rolls across the contacts, completing the circuit with absolute reliability and zero mechanical wear. Because mercury is a liquid, it provides a bounce-free contact, preventing the electrical arcing and signal noise that plague mechanical switches. For decades, these switches were the standard component in household thermostats, industrial tilt sensors, and even the mercury fuses used in naval torpedoes and anti-aircraft shells during the mid-20th century. Although they have been largely superseded by MEMS, micro-electromechanical systems, and solid-state accelerometers, millions of these switches remain in service in older infrastructure, acting as silent, silver-filled guardians of mechanical logic. The presence of mercury in the global atmosphere is also a byproduct of the massive combustion of fossil fuels, particularly coal. Coal is a geological sponge that has absorbed trace amounts of heavy metals over millions of years. When coal is burned in a power plant to generate electricity, these trace amounts of mercury are liberated and emitted through the smokestacks as elemental mercury vapor. While the concentration of mercury in coal is very low, often measured in parts per billion, the sheer scale of global coal consumption makes power generation the largest single source of atmospheric mercury emissions. Modern power plants are equipped with sophisticated scrubbing technologies, such as activated carbon injection and flue gas desulfurization, designed to capture these emissions before they reach the atmosphere. However, These systems are not perfectly efficient, and the captured mercury must still be managed as a hazardous waste product, often sequestered in specialized landfills or stabilized in concrete. This reality underscores the fact that the atomic age of mercury is not a historical relic, but a daily operational reality of the global energy system. Furthermore, mercury continues to play a critical role in the manufacturing of high-purity chemicals, specifically through the chlor-alkali process. This industrial method uses mercury cell electrolysis to produce chlorine and sodium hydroxide, caustic soda, which are foundational chemicals for the production of everything from PVC plastics to paper and soap. In this process, a flowing cathode of liquid mercury is used to facilitate the separation of salt and water into their constituent elements. While most modern chemical plants have transitioned to membrane cell technology to avoid the use of mercury, several large-scale facilities around the world continue to operate using the mercury cell method. These plants maintain massive inventories of the liquid metal, often hundreds of tons per facility, and require rigorous environmental monitoring to prevent leakage. The reliance on mercury in this sector demonstrates how the element is woven into the very fabric of the global chemical industry, serving as a catalyst for the materials that define the modern consumer experience. The chemical affinity of mercury for other metals, specifically its ability to form amalgams, is also utilized in specialized metallurgical processes and high-precision laboratory work. In the field of polarography, a method used to analyze the chemical composition of solutions, a dropping mercury electrode is used to provide a perfectly clean, renewable metallic surface for electrochemical reactions. This technique, which earned Yaroslav Herovsky the Nobel Prize in Chemistry in 1959, relies on the fact that each new drop of mercury is free from surface contamination, allowing for highly accurate measurements that are impossible with solid electrodes. Similarly, the mercury vacuum pump, or Sprengel pump, was instrumental in the 19th century development of the first vacuum tubes and incandescent light bulbs, as the falling drops of mercury were used to trap and remove air molecules from glass enclosures. These scientific milestones reveal that our understanding of the vacuum, the electron, and the atom itself was built using mercury as a primary tool. The management of mercury in the modern world is governed by a sophisticated understanding of speciation, the different chemical forms the element can take. Elemental mercury, Hg0, Hg0, inorganic mercury salts, Hg2 plus Hg2+, and organic methyl mercury, CH3Hg plus CH3Hg+, each possess unique pathways for environmental transport and biological toxicity. The ability of mercury to transition between these states, driven by microbial activity, solar radiation, and atmospheric chemistry, makes it one of the most complex elements to regulate. For example, the Arctic sunrise phenomenon involves a rapid chemical reaction where atmospheric mercury is oxidized by bromine atoms in the polar spring, causing it to fall out of the sky and accumulate in the Arctic snowpack. This results in high levels of mercury exposure for indigenous populations and wildlife in the far north, thousands of miles away from the nearest industrial source. This hidden mechanism of long-range transport demonstrates that mercury is a truly planetary element, oblivious to national borders and geographic distance. Ultimately, the role of mercury in our lives is characterized by a persistent and uncomfortable duality. It is a material of unparalleled industrial utility that has enabled the development of everything from the first light bulbs to modern MRI cooling systems. Yet, it remains an uncompromising biological disruptor. We have integrated it into the heart of our electronics, the extraction of our wealth, and the generation of our power, all while knowing that its presence in the environment threatens the integrity of our nervous systems and the health of the global oceans. The liquid silver of Einstein and the alchemists is not merely a scientific curiosity. It is a fundamental component of the human technological narrative, a material that reflects our highest achievements and our most significant environmental failures.
As we move toward a future that seeks to minimize the use of this forbidden metal, we are forced to confront the legacy of the millions of tons of mercury already circulating through the Earth's systems. The final block will explore the inevitable conclusion of this mercurial journey as we follow the path of element 80 into its final, inescapable state of permanence, revealing the ultimate fate of a material that refuses to be destroyed. The absolute permanence of mercury as a chemical element represents a fundamental challenge to the human concept of waste and environmental remediation. Unlike complex organic pollutants, plastics or synthetic chemicals that eventually succumb to the degrading forces of ultraviolet radiation, microbial metabolism, or oxidation, Element 80 is an indestructible building block of the universe.
It cannot be burned, destroyed, or neutralized into a permanent state of harmlessness. It can only be moved from one location to another, or transformed between different chemical species. This physical reality creates an inescapable mercurial debt for global civilization. Every gram of mercury extracted from the deep cinnabar deposits of the Earth's crust is now a permanent addition to the surface environment, destined to circulate through the atmosphere, the oceans, and the biosphere for thousands of years. The impossible cycle of mercury is a closed loop of redistribution, where the industrial emissions of the past are constantly re-emitted from the soil and the sea, creating a legacy of contamination that operates on a geological rather than a human timescale. The trajectory of a single mercury atom in the post-industrial world is a study in thermodynamic persistence. Once liberated from its mineral form and released as a vapor, the atom enters a global atmospheric cycle where it can travel thousands of kilometers. Eventually, it is oxidized and washed out of the sky, settling into the forest floor or the deep sea sediment. In these environments, it may be sequestered for centuries, only to be released again by a forest fire, the thawing of permafrost, or the shifting of oceanic currents. This process of remobilization means that even if all human-driven mercury emissions were to cease instantaneously, the concentrations of the metal in the atmosphere and the surface oceans would take centuries to return to their pre-industrial baselines.
The mercury currently circulating in the global environment is a mixture of new industrial output and legacy mercury that has been moving through the Earth systems since the Roman era, the alchemical age, and the height of the Industrial Revolution. This continuity of presence makes element 80 a permanent resident of the Anthropocene, a material that has been woven into the chemical fabric of the modern planet. From an existential perspective, the most profound impact of mercury lies in its ability to dismantle the biological basis of the human __68__. The human experience, personality, memory, cognition, and emotion is an emergent property of complex neurochemical interactions and electrical signaling across billions of synaptic junctions. Mercury, with its relativistic density and its affinity for the protein structures of the brain, acts as a literal '69 for the human soul. By disintegrating the microtubules within neurons and inhibiting the enzymes that regulate neurotransmitters, the element effectively erases the physical infrastructure of consciousness. The historical accounts of __70__ are not merely descriptions of physical illness. They are records of the systematic deconstruction of the individual. In the presence of high-concentration mercury, the traits that define a person, their patience, their intellect, their social connections, are dissolved, leaving behind a biological shell plagued by tremors and irrationality. This reveals a chilling objective truth. The most sophisticated manifestations of human evolution are entirely dependent on a delicate chemical balance that can be permanently overturned by a single heavy metal atom from a distant kilonova. The engineering efforts required to sequester this __71__ reflect the extreme difficulty of containing a material that refuses to stay in one place. Modern hazardous waste management protocols for mercury involve a process known as __72_S/S. Because liquid mercury is so volatile and mobile, it must be chemically reacted with sulfur to form a synthetic version of cinnabar, mercury sulfide, which is then encapsulated within a matrix of cement or specialized polymers. These stabilized blocks are then buried in deep geological repositories designed to isolate the element from the biosphere for millennia. This is the human attempt to restore the __73__ that was broken by our ancestors. However, the scale of this task is immense, as millions of tons of mercury are already distributed across the planet in the form of contaminated sediments, industrial sites, and consumer waste. We are essentially trying to __74__, struggling to manage a substance that nature originally intended to keep buried miles beneath the surface. The biological mismatch between mercury and life is further complicated by the __75__, a phenomenon that highlights the intricate chemistry of toxic survival. In the human body, the element selenium is essential for the production of selenoproteins, which act as powerful antioxidants and protect the brain from oxidative stress. Mercury possesses an incredibly high binding affinity for selenium, millions of times higher than its affinity for sulfur. When mercury enters the bloodstream, it seeks out and __76__ the body's available selenium, preventing the synthesis of protective enzymes. This creates a state of functional selenium deficiency, where the brain is left defenseless against the damaging effects of free radicals. Some scientists have hypothesized that the toxicity of fish like tuna is determined not just by the amount of mercury they contain, but by the ratio of mercury to selenium. This molecular tug-of-war is another hidden mechanism through which element 80 exerts its control, manipulating the very nutrients we need for survival to facilitate its destructive path through our cells. Looking millions of years into the future, the legacy of human mercury use will be preserved as a distinct chemical anomaly in the geological record. Just as we can identify the impact of the asteroid that ended the Cretaceous period by a thin layer of iridium, future geologists, if they exist, will be able to identify the era of human civilization by a sudden spike in mercury concentrations within the sedimentary strata. This mercury layer will mark the moment when a terrestrial species learned to extract the heavy elements of the crust and distribute them across the entire planetary surface. Long after our cities have crumbled and our languages have been forgotten, the mercury we released will remain. Some of it will have returned to the state of cinnabar, reabsorbed by the tectonic cycles of the Earth and subducted back into the mantle. Other atoms will remain trapped in the deep ocean floor, covered by eons of sediment, acting as a permanent metallic record of the brief and volatile mercurial age of humanity. The ultimate fate of Mercury is dictated by the cosmic timeline of the solar system. As the Sun eventually exhausts its hydrogen fuel and expands into a red giant, the temperatures on the Earth's surface will rise to levels that will vaporize even the most stable cinnabar deposits. The mercury that was once forged in the collision of neutron stars will be liberated once again, returning to the gaseous state it occupied in the early protoplanetary disk. In this final act, the living silver will be ejected back into the interstellar medium, continuing its journey through the cosmos. The atoms that once drove emperors to madness, protected the electronics of the space age, and contaminated the fish of the global oceans will be scattered among the stars, ready to be incorporated into the formation of new worlds and new suns. The story of element 80 is, therefore, a narrative of cosmic recycling, where a material of extreme density and danger serves as a temporary visitor to our biological world. The existential finality of Mercury is found in its role as a silent witness. Throughout human history, the element has remained a constant, reflective presence, mirroring the ambitions and the failures of those who sought to master it. It has seen the rise and fall of empires, the birth of modern science, and the dawn of the environmental movement. It has been a tool of the alchemist, the physician, the engineer, and the polluter. Yet, throughout all these transitions, the Mercury atom itself has remained unchanged. A heavy, relativistic, and indifferent entity.
It does not possess the capacity for malice or the desire for vengeance. It simply exists according to the fundamental constants of physics. The madness it induces and the immortality it promises are entirely human projections onto a substance that is fundamentally alien to our experience. Mercury is the cold mirror of the universe, reflecting the reality that our lives and our personalities are fragile, temporary constructs built upon a foundation of matter that we do not fully control. In the final analysis, the pursuit of liquid silver has been a journey toward the limits of human capability. We have reached into the atomic structure of the universe and pulled out a material that defies classical expectations, using it to build a world of unprecedented complexity. But the cost of this mastery is a permanent loss of environmental purity and a constant threat to our neurological integrity.
We have learned that we cannot play with the blood of the stars without being changed by it. The mercury in our environment is a reminder that we are part of a larger, more violent cosmic history, and that our technological progress is inextricably linked to the hazardous materials of the periodic table. We are a species that has been fascinated by its own reflection in a pool of liquid metal, only to realize that the reflection is toxic and the metal is eternal. The video concludes not with a resolution, but with a recognition of this permanent state of mercurial coexistence. As the final drops of mercury in a discarded sensor or a deep-sea sediment continue their slow, silent existence, they represent the ultimate triumph of the element over the observer. The mercury will outlast the memory of the person who mined it, the person who used it, and the civilization that regulated it. It will remain perfectly silver, perfectly fluid, and perfectly indifferent to the world it inhabits. Through trillions of years, as the universe itself trends toward a state of maximum entropy, these heavy atoms will be among the last complex structures to remain, cold and mirror-like in the darkness. We were merely a momentary chemical error that attempted to harness the liquid madness of Einstein, while the mercury itself remains the eternal witness to a sky that will eventually have no eyes left to see it. This is the final fate of the forbidden silver, to be the last thing that reflects the dying light of the world, a material that survived the death of stars to become the ultimate survivor of the Earth.